So what we do first is we look at satellite sea surface temperature data. You know all about it. You know you can identify upwelling through the appearance of colder water at the surface, because upwelling is a vertical movement. Okay, vertical movement of colder water to the surface, and you can see these. You can identify. So let's look at 4 subsequent years of March values. This is all from the Modus Aqua data. You can look it up what that means anyway. Okay, here we go. For data, March 2013, March 2014, that's the top levels, then March 2015, and then March 2016. And have a look at it. Just take your time, have a look at it. So if your grandma is with you, you might get her glasses out, have a look at it, All right, so what do you see? Well, the red stuff is warm water. Okay, and in this red is exceeding 20 degrees. And in 2013, you can see it almost covers the entire region, warm water. Okay, and the water that what's responsible for that is the South Australian current mainly. Okay, it moves warmer water, comes from the northwest and pushes warmer water into the region. It's warm and nutrient poor. South Australian current. All right. On the other hand, you also can identify upwelling plumes. Here you can see upwelling plumes. I get the pointer on. You see this area, upwelling. You can see it at the surface. Cold water, and the water is about, what is blue here, less than 17 degrees, 18, 17 degrees cold water. And if you spend your holidays there in this area, yes, Coffin Bay, beautiful Coffin Bay, Streaky Bay, you go there, and there's an upwelling event, you can actually feel the difference, You have to swim out a little bit, and you have to be very, very careful. Sharks around, plenty of them. But however, you probably missed the key point. It looks like there's little upwelling in 2013 and 2015 compared to the other years. And that's interesting, isn't it? You start to freak out a little bit, because what would happen if there's no more upwelling? What would happen to the sardines, to the tuna? Okay, some people are freaking out. That's a big surprise. Let's go a little bit more into detail. Let's have a look at chlorophyll A satellite data. Chlorophyll A is the green pigment of phytoplankton, and it's a measure of the phytoplankton concentration. So let's have a look. Same years. So at the top, give you March 2013, March 2014, then March 2015, March 2016. Oh, hang on. You can see the upwelling on the right-hand side. These red areas, this is when the chlorophyll A concentration exceeds 1 and reaches up to 2 milligrams per cubic meter. Keep it in mind, 1 is a good thing to remember for later on in the presentation. But hang on, there's something interesting here. Let's click on it. Where are the surface plankton blooms in these years? 2013, 2050, in the March. Well, there could be another month. Well, okay. By the way, if you're surprised that you can still see some red spots in particular regions like Streaky Bay here on the left-hand side, this is actually very likely a fake signal. If you have a very shallow water with sediment, and so this is a fake. It's not phytoplankton blooms here in this area, and here in this area. So this is a fake signal. Okay, so what you see in the other areas, these are real plankton blooms that you see in the coastal water. So the first surprise is actually surface phytoplankton blooms are missing. And if you look at all the 20 years of satellite data, they are missing in a third in 1/3 of all upwelling seasons, no surface phytoplankton blooms. And that's the first big surprise. That's shocking, isn't it? Where is it? What happens to it? Where's... Okay, big surprise. All right, but the story continues.